Live, so feel free to turn off your cameras. All right. Where did that go? Where did my... Okay, welcome. We give a quick intro about our speaker, Thomas. He's a software engineer at Pluralsight, and this is the third time he's presented for us. He attended Utah Valley University and that's where he learned C#. I guess this says it's his first programming language, and he's been working in C# ever since then. And worked in lots of different code bases at several different companies. And with that, turn it over to you, Thomas.
Hey, sounds good. Let me share my screen here. Go to center mode. Well, thanks for coming and listening to my rambles today about how hopefully you can use a new tool to improve your code base. Let's see. Let's jump into kind of topics that we're going to cover. We're going to cover kind of like immutable objects or immutable concepts, and we're going to talk a lot about records because that's going to serve as the basis. And we also have some code challenges too that we can run through. And I've got a Git repository here. If anyone's interested in cloning this repository, this is where I'll have all of my code, where I have all my code examples, as well as the exercises as well for you. Let me paste it into Zoom chat for you in case you are interested in getting to that. Let me hit to the Zoom chat. There we go. And yeah. So what is immutable programming? We've heard immutable before, and also immutable, right? So concept of immutable, right? It's not capable of change or suspect to change, right? So we either can change object or we can't. And so a lot of people really like functional programming because functional programming comes from this aspect of you have immutability in your object. That's like the default. And not object oriented, like usually that's not the case. Usually it's like everything can change. So kind of one of the things with object oriented, we can still achieve those concepts. So one of the things you could think of, right, is the string class is a really good example of kind of your immutable objects, right? It's like your string value can't change. That instance of that string can't change, but that string has operations on it. And with those operations, it will return you a new string value, leaving the old one intact. So why code with immutability in mind? We talked about it briefly, but it's like, right, objects can't change. That keeps us from, having our object change from underneath us. In case, especially dealing with a multi-threaded, application, that could, potentially cause side effects in your application or introduce bugs. That helps keep your thing intact. Also, potentially can simplify your code base by creating these immutable objects. You can also have a way to kind of track like your state differences of being like, hey, based off of all the operations that happened on this object, based off of my new one is like, did it actually change? As well as my favorite thing is in C#9, they introduced the with keyword, and the with keyword was something I wanted for a long time. I didn't realize I wanted it until I started using it and realized how great it is. So let's talk about records. And when I say records, I'm not talking about the vinyl records. We're talking about a new concept in C# that was introduced in like .NET 5, called record. It's a record type, very similar to a class. Sorry, let me back that. It's more similar to a struct type concept, but it's instantiated on the heap. So the records will serve as a primary way to do it, and there's some really cool features about records that make doing immutable programming way easier. Things I like about it that kind of finds out is the first thing is we have value equality by default with the record. With classes, you start out with reference equality, and so you have to change that concept. The Git hashcode is also based off of the properties of the object. We can also get a simplified class declaration, making our footprint of what we care about much smaller and easier to read, making our code base more maintainable. We can make records mutable or immutable. It's like, it's kind of up to us on how we want to code them up. As well as we get to use the new with keyword with records. And the with keyword allows us to create a copy of a record and changing certain properties of it. So let's talk about equality. So equality with records, we talked briefly about it. It's going to attempt to do value comparison first with record with your properties and like your fields, right, of your record, which is great. But there's also kind of like a side effect of that in the sense of a lot of your collections that you have. If your object has, arrays, lists, dictionaries, you name it, that those type of fields would use reference equality. And so that's something to keep in mind. Like in some use cases that works well, having reference equality. And other ones you want, maybe I need to actually compare the values of my collection in there to see what's changed. With records, you can still provide your own equality methods and get hash. That hasn't changed. It's just the way how you do it is a little different. With equals, you're not overriding your equality. You're providing an equals method, and the C# compiler kind of does some magic there for you, as well as your Git Hashcode. If you override your equals, you probably want to override your Git Hashcode. So let's go look at this code example to kind of see what I'm talking about here. For this, let me blow this up for everyone, and I will make this bigger. There we go. Let's see. Hopefully everyone can see that just fine. So here we have a simple record declaration. Here we're just doing equality, and here we can see we're just comparing, the reference type to see if it is equal to that, or going down to see if it's the reference equal to each other, and then eventually comparing the values. So like the thing to kind of want to point out is this piece right here where it says virtual bool equals. With a record, you have to declare it like that or make your record sealed, because if you do inheritance, they'll need to inherit that equals thing to override it potentially. So side note to remember. Then we talked about equality with collections, right? How kind of to reiterate, it's going to do reference equality first on those. And if you want to do something different, you have to manually achieve that yourself, right? One of the ways how I like to compare these is to use link to do that for me. I order the collection, I do the order by function, and then I just do the sequence equals function in link, and then compare my two collections to see if they're equal, to kind of show you an example of that when you care about comparing your collections together. Is kind of this example here where I have this array of emails that I'm going to order them by, just do string ordering. Then I use link to do sequence equals, and then I do the exact same thing on the other objects things and compare them. That's kind of one of the things I found, very useful with doing those collections. But, you have to keep in mind about if you have really large collections and doing lots of comparison on the objects in those collections may be kind of, intensive on resources. So, make sure you understand your code base on how big those collections are going to be before, you say, yeah, this is like the best approach for you to take on it. I'm not sure if anyone has probably done it. It's like you probably have dealt with Git Hashcode. I know I've dealt with it a lot. And I've always hated overriding Git Hashcode. And Git this thing got introduced before records, but they've made overriding Git Hashcode so much easier than it ever was before. They've introduced a new Hashcode class, just called Hashcode, and it has some nice functionality to it. They have a static function called Hashcode combine. We can just pass in objects to it, up to 8 objects to that Hashcode combine, and it takes care of all the other Hashcode math you have to do, right? You don't have to think about that. It's like, oh, do I have to do exponent to 7 or something and times these things? It's like, forget about it. This thing takes care of it for you. The downside is the hash combine can only do 8. So with that, if you need to do more than 8, you have to instantiate a hashcode object and add the objects to it yourself through an add function. You can add as many as you want. The only time I've usually had to deal with that is, for example, when I have a collection to do that, I know I'm going to have more than 8. So if we look at this example here, this is our first example of the hashcode combine, right? It's like, this has never been easier to override your hash code, right? Just boom, done, one liner of code. It's awesome. Then to do with the hashcode add, that's where it gets a little bit more complicated, but not much, right? So here we're going to instantiate a hashcode object, and then we're going to loop through whatever collection that we have, and we're just going to add the objects to our hash code. And then after that, you can do like hash code to the hash code value, or you can pass it into another hash code combine to generate a hash code for that. So that's kind of one of the really nice things that I've found in this language that has really helped me take care of hash code functions in C#. Let's see. I just realized I've been talking a lot. I've jumped through a lot of information at everyone. Is there any questions before I move on to more records? Let me pull up the chat too. So I just have it up here so I can see it. Okay. Take a quick water break. Okay, awesome. So by a default, records will use your properties for your Git hash code. So you only need to really think about overriding that is if you're overriding your equality. So that's something to keep in mind, right? So for example, if I create two classes of this, two instances of this hash code example with the same values in it, and I compare their hash codes, they will be the same, right? That's kind of something a bit different to think about, right? Because in normal classes, that would have given you a different hash code, right? So one of the other things about records that's really great is that they have a simplified declaration. So with records, they have this new thing that they call positional parameters. So these positional parameters allows you to define properties in line of your class declarations. You don't have to go through the whole process saying, define all your properties and create a lot of horizontal space, right? You can take that up on more of a vertical space and kind of decrease the amount you have to look at. By default, they're set up with the keyword init in that property concept. So once it's set, you can't change, where that reference is pointing to. Something to be in mind. It also generates you a constructor too that has all the properties in it by default. And you can make those values in your record optional by assigning, setting it to null or, assign it to a default constant value. And let's go look at this example here. So this thing here is doing a record with the positional parameters. And so I could define this all in one line, and it generates me a constructor and gives me these properties all with just, this simple line here. kind of in contrast of if I want to do a class or a record without using the positional parameters, right? This is kind of like the alternative to it, right? It's like you're defining your properties, and then you're defining your constructor, right? And then assigning those. So a lot of like extra stuff to look at when in reality it's it's a very simple like data class, right? We all have like a lot of times we're defining a lot of like contracts to, for example, like JSON objects, right? Like defining those contracts so you can deserialize or serialize, and you have a bunch of like space in there to define all your properties. This that I've noticed has really simplified our approach to designing those contracts, because now it's like our objects have shrunk, like our file sizes have shrunk a lot. They're getting really simple. Kind of these one-liners has made our kind of declaration of my code base much easier to look at for these type of data contracts. And we've been messing around these with JSON serialization too, and records have been working really great in serialization and deserialization as well. I think the only thing you have to really kind of be careful about with those, with records in that scenario, kind of going off script here, is when you're dealing with like deserializing something where because it gives you a constructor, and so since it gives you a constructor, your serializer can potentially choose to use that constructor, and so maybe that might cause you some issues. You may have to introduce like a default constructor that doesn't have any parameters in it to maybe help in deserialization. But those are kind of more more edge case scenarios that I've experienced. And we talked about this somewhat briefly, but right, with records, you can make them mutable, you can make them immutable. I kind of feel like it defeats the purpose of a record to make them mutable, but that's just me in my personal take in using them. I think it's kind of like, hey, if we're going to use these, like let's introduce that concept and make it immutable, because like by default, by using those positional parameters, it does the init concept on your properties, keeping them in a spot for you, so it's like they can't change, right? But that also can introduce some complications here with, for example, if we talk about collections. If you expose your collection in your record, and you just do like a list or an array, right? Now that record is mutable. Right, someone can go over there and assign a value, like change a value in that array property, or they can add a new item in your list or a dictionary. So kind of one of the things that I've liked to do so far is kind of like, hey, maybe I should expose that as a enumerable. So I'm clearly defining the contract of, hey, I have a collection here, like I have an array of a collection of emails on my object, but you can't change that value through like the property, right? It's like I'm kind of defining that contract there where I'm saying, no, you can't change it there. You have to change it elsewhere. Or also using immutable collections. That's kind of something new that I explored recently before doing this presentation. Is I found a whole list of immutable collections that take on the concept of, let's see, is the concept of strings, right? Where it's like, hey, if you want to add a value to this list, what happens is you do the add function to it. And what it does is it returns you a new list to you. That's also another way of maybe making your collections, your records immutable, right? When you're dealing with collections. And kind of like the thing that I've liked most about using records is the with keyword. The with keyword was something new that they introduced, I believe, with records at the time of .NET 5. But it allows you to do essentially like a copy of, it's like copy this record, change a value in this record, change the property that I choose to set it to, and now return me a new object of that record. Yeah. And that has really made things really simple with like defining immutable objects that have lots of values that are changing. Like I don't have to define like lots of constructors or different things of trying to make sure what is set and what's not set. I could just say, hey, copy everything over from the previous object and then just change these values. has really simplified the way of how like your code has to be organized and that it's a little weird to look at first, but it has really like made it really sleek on how to do that. So let's look at this code example here. All right, so at Pluralsight, a lot of teams love mobbing. So we've got this super programming game. I defined here. It's got a title, a genre, a number of players. So I defined this game, the super programming game, with saying that it can only have one player, but really, we should be doing mob programming. So we're going to up this to 4. Also, what's nice about this, I'm not, this kind of style preference of coding. I picked this up with a coworker of mine. He calls this the lazy comma, but you can keep a lazy comma there. So if you ever want to add to what you're changing, you don't have to remember to put a comma there. And then, right, it's like we just compare what's happened, right? It's like the object's now different. Like this one doesn't match up to the other one because the properties changed, but right, we can still see these other things, the values of it are true. So really nice. I really like using the with keyword. Okay, before we move on, I'd like to just take a moment again, just to see if there's any questions before I jump into more concepts.
I have a question, Tom. I haven't really heard of records before. It's kind of new, but I've been sitting in a hole just programming, legacy code and new code. How would you see a record be used in an application other than being like a functional programming type of tool? How would you use it in classes? Would you use it everywhere? Would you use it instead of structs? What's the idea behind the record other than having some cool features of immutability, etc.?
Yeah. So with that, like, right, it's like I still use classes in my code base, right? And classes in my code base kind of serve as more as what will be kind of like the business logic type ones. But then with like records, I've been using records as more as like defining our entities and also the data contracts. And a lot of my entities are kind of more of like been taking more of the domain driven design approach where they're like smarter objects, right? They're the kind of smart objects where they have kind of behaviors attached to them. And I've been using records there serving that purpose. So that could be kind of like a way to start introducing records is like, hey, do I have any data object that I want to kind of start clean up, look at ways of how I could use that easier? Well, hey, let's see if we can introduce a record into this code base. It also kind of depends on how like legacy we're talking about. If it's running like, right, if it's still running like .NET, was it 4 or 5 or something, or even older, right? It's like that's not an option for you. But that's kind of where I've approached doing it, is starting with entities.
Thank you.
You're welcome.
Just put a question in the chat, but I'll just say what it is. What about using records for DTOs?
Oh, yeah. So sorry, I didn't make that very clear. When I talked about kind of the JSON contracts, that was kind of what I was talking about. It's about DTOs, like kind of defining something simple that you're going to serialize and deserialize, whether it's JSON, XML, or something else. It's been working really great for us on my team at Pluralsight. It's really made our code much simpler to look at when defining the DTOs. So. Okay, awesome. Well, thanks for the questions. We'll move on. So kind of one of the things that I've been kind of describing this, and there's probably, a pattern name for it. I kind of looked at it a little bit, but I've just kind of, I decided to just call it the immutable object pattern, right? It's kind of the idea is, right, your properties can't change, and changes that are done to this object, right? You create a new instance with that change in that new object. And right, and it's like, and you use the equality for that. And so where we've kind of really used this idea, this immutable object pattern, is I will walk you kind of through like kind of what I had to deal with at Pluralsight. At Pluralsight, I work on an application that is, I essentially just call it like an aggregator of microservice. It deals with authorization. And so let me walk you through kind of like how this like solved our, like fixed our problems. Like let me introduce the problem here. So for example, we have, I actually clicked, sorry. Okay, there we go. So we have like multiple microservices, right? We got microservice A, B, C, right? Kind of define those names aren't too important, but right, we have these other microservices that the one that we work on, this aggregator, needs to bring their data in. And we take their data, like their entities, and we take and those entities then generate our custom entity in our BC. Well, part of these entities, right, is there like be a lot of data on those entities that your BC doesn't care about potentially, right? For example, like say you have like a user, like on identity service, and that user has lots of properties, right? You have, oh, sorry, did I start using BCs? Sorry, that is a Pluralsight term that they use for microservices. I was trying really hard to say microservices and wires flipped. Thank you, Steve, for pulling that out. I meant to say microservice, not a BC. That's just a term that they use at Pluralsight. So say this microservice, I've got this identity microservice that has this entity of a user, and that entity has like name, first name, email, right? UID name, all sorts of properties that come down into my microservice. And that thing events off like, hey, the user has been updated. Okay, cool. The user's been updated. Well, my BC only cares about the email. It doesn't care about the name, last name, or anything else, right? I only care about the email. Well, if that's the case, right, I have this whole event that came off, and now how do I know that my entity has changed, right? It's like, okay, for that one, I'm going to have to like compare emails and be like, okay, is my email different, right? And so we kind of have that same concept going to microservice. Sorry, I touched the mic. Microservice B to microservice C, all coming into this entity, and we're updating it, and then we go, okay, did our entity really change? Like, how do we check that, right? Simple solution is we just keep checking all the properties, right? It's like, hey, is that property different? That one different? That one different? And that scalability of that kind of gets a bit clunky, right? It's like they're all checking different properties. So I have to add a new microservice. I'm checking that property. It's like all different language there. So it's a little bit harder to track. Well, one of the things that I liked about doing this is like, well, okay, so I could take that entity coming from the identity one, right, and go, okay, hey, I'm gonna like, even though I'm just gonna take that the email is changed, like act like it changed at first, come in here, update my grab my entity out. I'm gonna update it, and then I'm gonna compare my old one to the new one, and then I can just say, are they still equal to each other? If they're still equal to each other, then it's like, oh, like it didn't actually change. No, like do a nothing. Or like if it did change, okay, hey, I do some type of business logic based off of that trigger. And so now I can apply that same concept to microservice B, microservice C, where I can say, hey, my subscriptions to like this user subscriptions, like did they truly change? Oh no, they're still the same as before. Okay, I don't have to trigger anything off of that. Right. So it kind of really starts to simplify where that logic lives and like your kind of contract. So it's all kind of like consistent, right? I'm not checking multiple different properties. I'm just doing comparisons off of my original object to my new one without having to go like reload the database or do some type of state tracking concept in my class, right? Doing state tracking can be, a bit complicated, storing all those values to see if it really changed, right? I could just store my original instance and get my updated one and do a comparison. So that's where this kind of like immutable programming concept has helped us a lot to simplify our code base and to make really like meaningful events happen in our code base where I could say, yeah, that user really changed. Like it had a change on it that I truly care about. It's updated. Or if I'm worried about like data loss, right? Because it's none of my data. Like my microservice is replicating data over. Well, part of that replication, right, is like you could potentially have eventing loss, right? Things happen where things can get stale, right? So that's also another thing. It's like going to get that data again. It's like, okay, hey, I'm gonna go read your state to see if your email will change. Well, it's like then I'm doing all those comparisons like that on all those different properties. I can just update the object, do a comparison, and move on with life. Let's do this is a pretty simple example of that. All right. So I've defined this plan, and by the way, I did overwrite equals in here to kind of show like I wanted to take on the example of I care about what the values that's in the collection because that was a big use case for us is caring about those, and also that was difficult because like we're reading out the object out of database, getting the object from like an event or like an API call. Those objects are going to be the same immutable list, so we really cared about comparing the collections. So I've got this plan defined. It's got an ID. It has a list of subscriptions. I've got this user. This user has an ID, a name, email address, list of subscriptions tied to that user, a plan it could be on. So and I'm checking all of its equality here, right? As I can. I'm checking to see if these are still the same. Did anything change? And so kind of my example logic is say I have some type of event that happened, right? Some type of event, whether it's like user updated, maybe some subscriptions change, or they got added to a plan, removed from a plan, right? There's all sorts of things that can happen in your microservice world. Well, it's like, hey, I handled that event. I updated my user. So, this is, really you'd be returning that from like your database or something like that, right? And this email would be coming from your, like your actual Rabbit message or your API call, right? Kind of side point, just keep it very simple here. And then we would just check to see, okay, hey, we got our user, we're going to update our user. And now it's like, is the user different? And if it's different, let's trigger some type of business logic. And then that becomes our way of interacting with these objects is we're no longer checking like properties and doing all sorts of things. We just introduce that change into our equality, kind of put it where it should own it, and then just check the objects against themselves. And so that's kind of how we've been working in my code base of doing kind of our simple checks here. We've really been enjoying that. It's worked pretty good for us. So before I move on to some code exercises, are there any more questions?
Got a question in the chat.
Okay. Yeah. Yeah. So Carter, yeah, you can use inherits with records. You can't inherit. I show me a slide for that. You can't inherit from classes when you do a record. It has to be from a record type or interface. And just like inheritance, it serves its purpose, right? So make sure you use it wisely. So. Kind of the standard that we've been doing more is just doing a lot more composition, right? Been favoring more of the composition over inheritance, but that's just kind of the style that we've programmed and do very little in inheritance. So besides interface inheritance, that's the thing that we've used most. Okay, cool. Well, let's move on to some code exercises. With the repository, feel free to do these with me. They're pretty simple. They may be a little boring. I'm sorry. I was just trying to keep it to concise to the point, especially since we don't have a lot of time, in the meetup to spend a lot of time on the exercises. So let me pull up our code base here. Go to our exercise, and in the Git repository there, I do have a branch there for the answers to see how like I did. If you would like to, reference that, you can switch to, I think I called it the answers branch. You can look at it there and see it. So, okay. So for exercise 1, I will move this over to this side. Is we have a simple class here, right? We have 2 properties on it. And we have a name and email, and part of that is this record likes to uppercase the name property for whatever reason, right? So let's simplify this by turning it into a record and how we can use a provisional record. So if we change class to record, pop over here, add the parentheses, right, and then we do string. And here we want to use the capital N, because the capital N, right, is this gets turned into a property. So the naming, convention would be a capital here, right? And also do it to the email. And here we're saying email is, an optional value. And if you don't provide it, we're going to default it. So we're going to copy that, paste it in here. And now I've made that, an optional value. But so since it gives me a property of name already as part of this definition of defining with positional parameters, how can I uppercase this name now? Well, with that is you can define additional properties with the same name to replace what your positional one is, to do something a little different. So I could define it like this. And so by doing it like this, I then uppercase my name property when it gets created. It looks a little funny. My team and I have kind of scratched our heads a few times, being like, what's going on over here? It's like, that seems a bit strange. But yeah, it's a way to kind of change kind of values on that. So now if I run my test, hopefully it passes, right? It passed. Woo. Live coding, right? That's always dangerous. Let me make that a little bigger for everyone. I realize I'm on an ultra wide. I should have mentioned that before. So sometimes aspect ratio can make it a little small. So hopefully that's a little better for everyone to see. Okay, that's code exercise 1. Code exercise 2, right, is we want to make a positional property on our record so that it can't change. So kind of why you might want to do this, right, is one of the things that I think on a record, right? So say I've got a user object, and that user object has an identity property like filled, right? It's got some ID on it, right? Kind of changing that ID with the with seems strange, right? Because now it's no longer related to that identity. So there's a way to do that with records in terms of preventing that. And the way and how you would prevent that is very similar to how I set that property value here. So if I come in here and create a property, and it's a GUID. And I name it ID, and I take away the set and assign it to the ID, set that and add my semicolon. I now prevent my identity from being able to be changed with the with keyword. Like how important is that? That's kind of more I would probably say more of like a preference than like I'll say a necessity. but you're not going to be always owning that code base, right? It's like people move on, code bases change hands. So it just helps you enforce that type of contract, right? Of saying, hey, you shouldn't be able to change the identity with the with keyword. So I'm just gonna comment this out because, right, I want to be able to run the other tests to show you, and I can't do that when I have a compilation error. Okay, so code exercise 3, we're gonna kind of get into a little bit more about, hey, how can I keep my modifying kind of property values and making sure that it stays the value type that I want, or I ensure the edits on it. Because there's one thing I didn't talk about code exercise 1. With code exercise 1, the way how I did this property, if you use the with keyword, and to create an instance of this and change name to something else, to instead of General Kenobi, right, change it to Obi-Wan, that name value will not be uppercased. And we'll get into how with code exercise 3 on how to modify a value, including when it is done with the with statement. Okay, so if I come in here and run my tests, it will fail on my assertion, right? We got one fail. Oh no. Okay. All right, cool. Let's fix that. So with this, we want to remove the ticks from our date last updated, right? Kind of one of the reasons why we want to do that, right, is like if you're working with databases, right, especially like Postgres does not save down to that precision. It only saves down to the milliseconds. So how can I ensure that I still have like equality on my timestamp when I am doing like unit testing, like integration testing to my database, save it, get it out, compare it. How can I make sure my timestamps still equal each other? Well, kind of similar thing that we've been doing, right? Let's add in another property that would replace our last updated. But what we're going to do is we're going to do something a little different, unfortunately. What we are going to do is we need to add in a backing property for this. And we're going to assign it to last updated. So just like how you saw in the previous ones of me being able to assign over properties, I can assign it over fields as well instead of properties. And so then what this will end up doing is this will then end up returning last updated. And then my init will set last updated to the value, right? Okay, so now we've kind of defined how we're going to set these values, but now we still have to remove the ticks from that. And let's introduce a function here so we can just reuse that. And I'm not talking about the ticks that suck blood. I'm talking about the the ticks on your CPU clock. But you can think of whatever one you want. It makes it more interesting. So we're just going to copy this. I gave everyone the answer of how to remove the ticks. But we've got to come over here and change these values here. Live coding and keep it as simple as possible. I'm not going to try to do anything fancy. We're trying to copy and replace, search and replace things. I don't want to actually replace anything else. Okay. It's a little repetitive. And so then we call the remove ticks. Oh, there we go. Oh, sorry. I forgot to make it static. That's important if I'm going to call it like that. And I got to make sure I call it the same thing. And then with that, right, if I run these tests now, I will ensure that when I create when I use the with keyword on this object again, and change my last updated, that it ensures that, oh wait, hold up. Oh no, live coding. Man, I should have been more careful with live coding. Okay, my test, oh, still failed. Oh man. Okay, well, I was running through this earlier and I got it, and now I messed it up. Okay, well, that's always fun to see that. To, you know, the joys of live coding and not want to spend too much time on why I messed that up. Let's go look at my answer to make sure I didn't do see what I messed up here. Yeah, okay. Well, the only thing really different from I see from my answer is
One thing
Yeah.
on line 9, the name of your variable is last update. And I'm seeing last updated on the stuff on the right. I don't know if that difference is important.
Oh, yep, yeah, you are right. Sorry, the joys of accidentally, oh, oops, that was not what I meant to do. I'm so used to doing Control RR because they're, writer and resharper. Steve, thanks for pointing that out. Yeah, that completely matters, right? I, by introduce this property, I wanted to replace what this one was, and I did not replace it. So I have to make sure I add the D there. Thanks for pointing that out, Steve. And now that when we run that test, we will see that it passed now. And that's why we do mob programming. So code exercise 4, this is kind of one of the things that of how I've kind of been designing my entities at Pluralsight with kind of that immutability in mind, and using the with keyword. So with exercise 4, I've got this user object, right? And I've defined kind of properties on this object and functions on here. Well, it says, hey, I've got this email that can be updated. I've got a name. I've got additional email that I can add to my list of emails. I can remove emails. So with that, right, it's got a set of tests if we run, right? Some are kind of set up to pass right now anyways, but some will fail, some actually, they all failed. Sweet. So we have these things. So I'm going to define kind of the functionality, because now when I've defined this, I can now define how I update my email, right? If I wanted to add in business logic of being like, oh, hey, is it actually the same thing? Or is that actually a valid email, right? It's like, there's all sorts of things that we can do here to define like this entity owning that change, right? And this is kind of one of the things I like about it, right? It's like, hey, I return the new user. It looks a little funny, it's like quite a bit different from like your normal way of looking at code. But you can see that change of, hey, we're using this keyword with this and saying, hey, we're updating our email. All right. And now when we run our tests for our email updates, we'll see we now have some passing. Woo, we did it, right? Easy peasy. So now when we come up to name, all right, we can then say, define that for name, right? Just very similar to what we did. And boom, here we go. We now have 2 more tests passing. All right, and now let's say, hey, we got additional emails, right? So if we go to additional emails, and we assign it to our we add the email, right? Boom. We got additional email, and now let's copy this because it'd be very similar for our remove email. Instead of add, we will call remove. Oh, but we need a capital R. That's important. And now we've defined kind of like our contract of how our class works. We can do updates to it, right? And we define that new user, and we still have a record of the old user, so we can use it in comparisons down in our other business logic. So, and that is all that I have for you today. That is kind of how we've been doing immutable programming in my code base at Pluralsight. So thank you for listening and hearing my ramblings. I guess we still have some time, but I guess if you have any more questions, I guess now's the time, right, to ask those.
That's right. Now's the time.
I could see some uses of this for applying DDD principles in software development. You could keep your domains solid and transmutable between each of other domains by having records. I think this is the main emphasis of records after all.
Yeah, I agreed. It's I worked on a code base that was very much like, if you read about domain driven design, it talks about like you kind of have like these anemic models or like these anemic entities. We're in a very anemic state, and that caused us to have some challenges because we had like subscriptions, we got plan data, we got this block stash from this user type thing. And so kind of tracking all that change was very hard because they didn't have like really good things to it. And then we kind of did domain driven design concepts, created an entity out of that using records, and we had like a much richer code base. We were able to really like expand how our entity changes. Since doing that refactoring, like we've been able to like add in new functionality really easily, and adding new data into that concept as well has been like a breeze. And like our PM has always been like, oh yeah, that's like, it's like, oh, every time we have something new come up, you guys like get it done so fast. I was like, yeah, it's like that refactoring did it for us. It made it easy for us to do it. Okay, cool. Well, I guess with that, I'll turn it back over to Steve and Caleb. Thank you, everyone.